All right, today we're going way beyond just basic AI chatbots. We're actually diving into the architecture, the real blueprint for building a much smarter, more capable AI brain. See, the most powerful AI systems out there, they don't just respond. They think, they track, and they evolve. So let's get into it.
So what's the secret sauce here? Well, it all comes down to context. The best way to think about it is like an AI's working memory. And it's not just about remembering the last thing you typed, no, it's about understanding the entire flow of the conversation, what the goal is, and even pulling in facts about the world. That's what makes the difference between a simple tool and a real problem-solving partner. Okay, so if context is the key, then how do we actually build it? How do we engineer a system that can juggle all this information without dropping the ball? Well, in this explainer, we're going to build one, step by step. First things first. Our first, and maybe the most fundamental step, is giving the AI a memory. Before it can tackle anything really complex, it needs a way to write things down for itself and keep track of what it's doing.
What's so cool about this is how much it's like what we do, right? When you've got a big project, you don't just try to keep it all in your head. You break it down, you make a to-do list, you jot down notes. It's the exact same idea here. By letting the AI write its own internal notes, like how it's breaking down a task, the little results it's finding along the way, and even why it made a certain choice, we're giving it this incredible tool to handle really complex, multi-step problems. This is the big leap from just a reactive machine to a proactive agent that can actually manage something.
So, our AI has a memory. That's great. But what about all the information it doesn't already have? Well, the next step is to connect that brain to the outside world. This is basically how an AI gets its senses. It's no longer stuck with just its training data. Now it can query a database for specific facts, make an API call to get live stock prices, search a company's knowledge base for policies, or even pull up your personal preferences to tailor its response. These are like the digital threads connecting that AI brain to a world that's always changing.
Okay, so our AI has its own memory, and it has access to pretty much all the world's information. But that creates a brand new problem, doesn't it? Information overload. How does it possibly find the signal in all that noise?
And this slide just perfectly illustrates the challenge. An AI that's getting flooded with a ton of irrelevant context, it just gets slow, it gets inefficient, it can even get confused and give you bad answers. It's a real paradox. Too much information can be just as paralyzing as having too little. So what we clearly need is some kind of filter.
And that filter is context compression. This is all about giving the AI the ability to focus. So instead of just dumping a giant, messy wall of text on it, the system can summarize it first, pull out only the most important points, and then structure everything into a clean, easy-to-use hierarchy. This keeps the whole system running efficiently, and it makes it token smart, which is just a fancy way of saying it uses its brain power wisely. And that is absolutely essential for performance.
Now that our AI is nice and focused, we have to start thinking about safety and organization. Just like our own brains have different sections for different jobs, a really well-designed AI needs compartments. It needs walls in its mind.
And that is the power of isolation. By creating these separate, protected chambers for different kinds of context, we make sure they don't bleed into each other. So task-specific data stays with the task it belongs to. Your personal information stays secure. And temporal context helps the AI understand the proper sequence of events. Think of these as digital firewalls, and they are absolutely critical for building systems that are not only robust, but also trustworthy.
So far, we've designed a single, really powerful AI brain. But what happens when we need a whole team of AIs to work together on a problem? Well, this brings us to our final and maybe most advanced step. Right. In systems where you have multiple AI agents, communication is literally everything. They can't work as a team if they're not sharing what they know. The way they pass context back and forth, exchanging these little structured packets of data, that's the magic that allows for really complex, coordinated teamwork.
And this brings us to a really critical insight. Every single action an AI agent can take, every tool you let it use, every piece of context it can share, that is a decision point. A decision point that you, as the architect, have designed. For instance, if you give an AI the ability to book a flight, that's an implicit decision to trust it with your travel. The way an AI acts is a direct result of how you designed it to decide.
So the huge takeaway here is this. The intelligence of an AI system isn't just in the model itself. It's in the architecture you build around it.
The way you structure the flow of information, the tools you give it, the rules you set, that is what ultimately defines how smart that system can really be. So let's just quickly recap the blueprint we've put together. We gave our AI a memory. Check. We connected it to the real world. Check. We taught it how to focus, we made it secure, and we enabled it to be a team player. Every single step was about engineering the right context.
These 5 strategies, they really are the foundation. This is what transforms a simple language model into a truly intelligent system. This is how we're going to build smarter, more capable AI agents from here on out.
In the end, it all comes back to design. The power is in your hands to structure the context and to control the flow of information. So the final question I'm going to leave you with is this: how will you design the intelligence?